Today we talk about sandwich term, which is one of the ways to prove the function or the sequence, whether it is convergence or it is divergence. As the name says, sandwiches, when you think of sandwiches, you should think of like the bread, and we put some cabbage, some tomato, some ham, some cheese in between. And then finally we end up covering another bread. So in summary, there's 3 layers, a very simple sandwich. So the same concept for the sequence where how do we prove its convergence. Let's say the thing we're going to find is in middle is B sub n. This is the sequence we're going to find whether it's converges or diverges. So we say it's sandwich, so this number is in between a number which is bigger than Bn and also smaller than Bn. Let's say the number bigger than Bn is C sub n, and the smaller than Bn is A sub n. If C sub n, this sequence, is converges, and this is converges, and very logically we can say this number Bn is converges right now. So right now I draw a graph to show you how it looks like when it is in the graph. Let's say I plot this graph up. Okay. If this sequence is Cn and this sequence is An, so Bn should be some point, the sequence in between. It can be like this, it can be like this, anything. And if this Cn converges and An converges, and very logically, we can say that this Bn itself converges as well. So right now we look at some of the example on how we can use this concept to apply in our questions. All right. So first I'm going to show you a simple one. Let's say limit n approaches infinity 1/2 power of n. For this, I just show you how the ordinary method is. We sub the infinity here, and this is equal to 1/infinity, which is equal to 0. It means this is converges. Because converges to 0, the point is 0. In order to use this sandwich theorem, I'm going to say that this sequence, this is my sequence. Let's say sequence here is my Bn. Then it is smaller than some sequence, and it is greater than some sequence. So I can say it is at least greater than 0, but it is smaller than 1/n. Because where the bottom here, the denominator number increases, so the overall number will get things smaller. Just like 1/5 is smaller than 1/2 because this increases is 0.2 and this is 0.5. This concept. Okay, so when this limit and approach infinity for 1/n and limit and approach infinity for 0, obviously this 0 will give us a 0. We converge at 0, and this one is infinity, also will get 0. So if this is converges, obviously we can straight away say that the limit when n approach infinity for 1/2 power of n, this is also converges. And this is how we use the sandwich theorem to show it. Let me give you another example. Let's say we have limit n approach infinity for -1 of n or n. So again, we're going to put it as a sandwich. This is in the middle, right? -1 of n over n. So what kind of number do you think it is smaller bigger to? Can I say, because this is negative 1 power of n, for any number, the maximum, let's say for any number, as long as it is even number, then I should get is positive 1 over n, right? So positive number should be greater than this one. And the lowest one is I will get negative number in front of n. Then I will try to do the limit at both sides. At limit and approach infinity. Okay, for this case, I solve this one first. We get 1 over negative infinity. So what we get, negative 1 over infinity, and a very small number divided by a very big number, you get 0. Negative 0 also will get 0 as well, right? Where you get 0 means that this sequence will converge at the point 0. And solve this one, we substitute 1 over infinity, and we get 0 as well. So therefore, this sequence will also converges at the point 0. So this converges, then we can say this also converges at the point 0. And we prove it that this sequence is converges. Okay, let's try another one more example. You can pause a while and try to do this example. Limit when n approaches infinity, cos n over n. Again, we use the sandwich term. I put it in the middle, cos n over n. So what is the largest number for cos? As you sketch the graph of cos, so from 1, here is 1, minimum is 0. Oh, sorry, minimum is negative 1. Okay. So same here, I will get 1 over n, and I'll get negative 1 over n. And when I put the limit at all the side here, when n approaches infinity, okay. This one, also 1 over infinity, so we'll get 0 as well. And for this one, 1 over infinity, you get 0 as well. So since this converges, and this also converges at the point 0. Okay, so that is for the sandwich term. And next video, we're going to talk about L-hospital rule. Okay, see you.